Let's graph this function. P and Q are parameters. We don't know their exact value. So let's first find our asymptotes. This is in reduced form, so our asymptotes are going to occur when the denominator is 0, which happens when x equals q. I don't know where q is, but I know it's positive, so I'll put it right here. For horizontal asymptotes, the shortcut is to look at the behavior of the ratio of the leading terms. So in our numerator, we have a negative x squared for our leading term. In our denominator, it's an x squared, which equals -1. So our horizontal asymptote is y equals -1. Now let's look at intercepts. For x-intercepts, we have a 0 and we have a -p. Now p is positive, so -p, I don't know exactly where, but it's somewhere on the negative x-axis. For our y-intercept, we plug in 0 for x, and that gives us 0. So actually the y-intercept is one of the x-intercepts. Now we just need a starting point. Let's go ahead and start at -p0. As I go to the left, I know I have to approach my horizontal asymptote. So I'm going to go like that. Now -p, this factor that it corresponds to, has multiplicity 1. It's odd, so I know I'm going to cross. I also know I have to go back down so I can go through the 0, 0 intercept. Now I have a choice. I can either go up or down when I get to the vertical asymptote. Well, x has multiplicity 1, which is odd, so I know I'm crossing. If I went up, I would have to go back through the x-axis, but there's no more x-intercepts for me to cross at, so I know that this has to go down. Now let's see what happens as we cross over the vertical asymptote. The multiplicity of x minus q is even. That means I stay going the same direction. Next, I'm going to somehow end up along this horizontal asymptote. I need to think about whether I'm going to cross with a little bump or not. If I did, I'd need more x-intercepts. I don't have them, so it just goes like this.